Hello everyone, we are Group 39. Our project is a Yelp recommender system, and we want our recommender system to be your best restaurant finder. Here's an overview of recommendation system. It's usually done in two approaches. The first one is called collaborative filtering, and second one is called content-based filtering. For the CF, it's usually done by making predictions about the interests of a user, by collecting preferences or taste information from other similar users. The pros it has are we don't need the domain info about a specific area, and it can provide great serendipity, and the computation is light. However, it suffers from the cold start problem, and it's also hard to include side features such as dietary restriction. For the CB filtering, it's done by using the description of items and users' interest. Items with features overlapping a lot with users' interests are recommended. While it can provide consistent and personalized recommendation, it lacks of serendipity. So we propose a solution, hybrid recommendation system. We deploy collaborative filtering and content-based filtering in the same time. Like I said, the CB can be done because we have detailed info about the restaurant, and we can extract users' interest from their reviews. Therefore, the cold start problem can be addressed, and said features are included by CF, and the serendipity is supported by CF. The dataset we are using is from Yelp public dataset. We used reviews, business, and users.csv, which has a combined volume of 8.7 gigabytes. After we done the data cleaning, such as deleting the non-restaurant business and deleting the non-active users, we still have 3.8 million reviews left and 55,000 restaurants and more than 290,000 users.
So here is our system. First, we use collaborative filtering to process the stars of review dataset. We can predict stars by collaborative filtering, and use these stars, we can do rough recommendations. So we can get 50 recommendations. And for content-based filtering, first we use LDA and sentiment analysis to process the text from review dataset. We can get user topics and business topics. These are some examples of topics. And then we can compute the topic similarity. Also, we can get business categories from business dataset, and we can get user categories by aggregating business categories. These are some examples of our categories. So finally, we can also get the category similarity. So in the end, we will use topic similarity and the category similarity to do a final selection from 50 recommendations. And these 10 recommendations is our final output.
For our pure CF part, we used the singular value decomposition matrix factorization method, which is a model-based method. We assume users and items features can be mapped into lower dimensions. These lower rank matrices are updated using stochastic gradient descent method to maximize log likelihood. So we've defined a matrix to evaluate our model. The MAE stands for mean absolute error, and the AUC4 score stands for the area under curve score with 4 stars as a threshold defining a good restaurant. ACC stands for accuracy, and we define delta 1 to be the proportion of our predictions that lies within 1 stars from the ground truth. For the pure content-based filtering, we are training a support vector regression model with topic similarity, category similarity, average stars, and total review numbers as features, and to predict final ratings. So here's a matrix to evaluate our hybrid model. You can see compared to the CF model, we decrease the mean absolute error and we increase the area under curve 4 score. When comparing with previous work, which is published on AAAI, focusing on IMDb reviews, our dataset is 100 times larger than theirs, and our CF matrices is 10 times more sparse than theirs. They used a content-boosted CF method, which is different from ours. We use a cascade hybridization method to combine our CF and CB scores. Although with such a difference in datasets and matrices, we achieved an improvement of same magnitude.
So finally is about our recommendation website. We use Vue and MySQL to build the front end, and we use Django and Python to build our backend. We will show our demo on the end of our video. So thanks for listening. Here are some main parts of our code. And the first is business pre-processing. So we read the data and we drop some columns, some useless columns, such as some columns are related to time or location. And we do the data cleaning for Boolean variables, enum variables, and dictionary variables. For Boolean variable, in the original table, some values could be yes or no or 0, 1, and true or false. So we have to make them just true and false. Then we delete business which are not restaurants because we only focus on the restaurants. And then we save the data. And for user pre-processing, we only select 4 columns. And for reviews, well, first we delete reviews given to businesses which are not restaurants. As I said, we only focus on the restaurants. And then we delete reviews given by inactive users. Inactive users are those users who only have at most 5 reviews. So finally, we process the text column because we have to process this table in the Spark. Then for the LDA part, we implement LDA on the GCP by PySpark. So we read the data as RDD and we pre-processing that. And we use TF-IDF to get the frequency for each word. And then is LDA part. We use 10 clusters, so we just get the topics for all the reviews. Then we save the data because it takes a lot of time to transform the RDD into the data frame. So we just transform and save the data in batches. And the sentiment part, we use the VEDAR in NLTK library, and we get the compound score for each review, and then save it in the CSV file. The next part is topic. We use LDA and sentiment analysis, and we can get the topic and the sentiment for each review. So we can get them and normalize the topic matrices. And for business, we have to use the sentiment part, and then we just save them. And for categories, we can get the categories by in the business dataset. And first, we filter all categories, and then we delete unwanted categories, which are at least 20 frequencies. Yeah, 20 frequencies. And we can aggregate the users category by the business the user have been visited. And also we have to normalize the user categories. So the next part is final preprocessing. We have to make a final matrix. First, we read the data and we compute the topic similarity between all users and all businesses. Also, we have to compute the category similarity between all users and all businesses. And we try to use SVR for the content-based filtering. So we add the review count and the average stars in the matrix. So the final matrix looks like that. We have 7 columns. And for the final part, we have to train and test our model. So first we read the data and we slip data for both collaborative filtering and content-based filtering. The test size is 0.1, yeah, 10%. And we use grid search to find out the best hyperparameters for collaborative filtering. And then just train the model. And we can save the self model at the Pico file. So the next is testing. Yeah, so we test our data for pure CF and the cascade CBNCF algorithm. And we can print all metrics to compare them. And we find out that our hybrid recommendation system is better than the pure CF. So here is our recommendation website. This is our main page. Here you can input your user ID, and I will paste one. Then you can search. If you have already signed up for our Yelp, then your user ID is already in our database. So we will search it and we'll output your name here. And we will give 10 recommendation restaurants for you based on your references. And if you are a new user, then we design another page for you. So here you can select some categories that you are interested in. For example, you can select many of them. And our algorithm will recommend 10 restaurants for you only based on the content-based filtering. Only compute the category similarity. Yeah, so this is how we deal with the co-star problem based on the content-based filtering.